Good morning, Mr. Tucker.
Good morning. Good morning. How's it going?
Good, good. I had a quick question for you, not math related, but
hmm
college related. Do
hmm
you know, I'm trying to pick out my classes for this upcoming semester. What's the difference between a virtual and a Zoom? Because the classes, some say virtual, some say Zoom.
I think they're the same thing. I think maybe certain now are they at different campuses?
No.
No, same campus.
I will
What
check. Good.
I have a virtual class. Virtual means you don't do Zoom. You just get assigned the work on Canvas and you just do yourself.
Oh, okay. So that's online. Okay. So
Okay, so just straight online learning.
yeah, right.
Yeah.
So that makes sense. So instead of using online versus virtual, because that's really the terminology is online versus virtual. They're using Zoom and virtual. So virtual really, I'm just saying how it really is supposed to be said. On learning online is when you just do stuff asynchronously and you just throw a bunch of information at students, and then I'll sit in my office hours if you decide to show up. That's learning online. So they're using that term as virtual. And then Zoom means you learn synchronously like we're doing today. This
Okay.
type of class is Zoom. So like any classes I have will be Zoom. So this is what we're doing, but so going with Mr. Logan's saying that the virtual is, you don't see the teacher unless you go to their office hour, and then they just throw a bunch of stuff at you, videos and whatever, and you learn on your own
Yeah.
time according to the due dates.
Yep.
Okay, thanks so much. That's very helpful because I cannot do virtual. I have to do Zoom or in person.
Yeah, I was just gonna say that sounds miserable. Like, here's all this work. Awesome. I'll see you in 3 months when I have 2 hours to do it all.
Right.
I have a virtual class for mythology and arts, but she does you can attend a Zoom on Thursday. You don't have to attend it. You can either attend it or just watch the video. But if you do attend it, you get extra points on the exam.
Okay.
That's why I attend it every Thursday.
Right. That's a good look now. And some instructors don't offer that, so that's good on her part. So yeah. Cool. All right, guys, we have one more section in chapter 3. I know you guys can't wait. We're looking at 3.6 today. Bless you, Mr. Williams. And then from there, we'll talk about what we're going to do next class. So, like I mentioned, what's supposed to happen either last week or week before last, the department head, dean, is supposed to be coming in this Wednesday. So just let you know, but we're going to be doing something different. So I'll tell you that after we get through this section. Just had an idea given to me, so we're going to try it out. Hopefully you'll like it. We'll see. But 3.7 modeling using variation. So looking at the first one, which is direct variation. Why can't you guys stay on my screen? I don't get that. Let's try this. It still didn't work. Okay. All right, so first relationship we're looking at is direct variation. We have y varies directly as x. Y is directly proportional to x. So if we see either one of these phrasings represents direct variation, and we're going to set up our equation this way. Y equal to kx. So we're going to have what's going to happen in this section. We're going to have specific phrasings that we're going to be looking for. And those phrases are going to tell us how to set up our equation, how to set up our problem moving forward. So if we see direct variation or varies directly, directly proportional to, we're going to use y equal to kx. What comes before the variation is your y. What comes after that phrasing is going to be your x. Oh, also, K is your constant of variation. K will be involved with all of these problems. So K is your constant. It's your constant of variation. So just give you a heads up. We got some word problems to write for those who want to write them down. So all right, let's scroll up some. Of course, if I scroll up too far, let me know. All right, the first one, the distance that a body falls from rest varies directly as the square of the time of the fall. If skydivers fall 64 feet in 2 seconds, how far will they fall in 4.5 seconds? All right, so scrolling up some. Now I'm going to give you the steps for basically be a blueprint to solve all of these problems in this section. If you follow the steps, follow the flow, you should be able to get to solve these. I won't say with no problem, but you should be able to solve them. So the first step is identify the variation setup or identify the phrasing. We already see here that this varies directly. So we're going to use this setup, y equal to kx. Once again, all of these problems will have a key phrasing that's going to dictate how you set up this problem, or set up the formula, or establish a relationship. Second one, you want to establish your variables. Remember, what you're doing is looking for your phrasing, and then what's in front of your phrasing is your y, that first variable. What comes after your phrasing is your second variable. So before the phrasing, I have the distance that a ball falls from rest. After the phrasing, the square of the time t, or the square of the time of the fall. So that's why I call d distance t time. What you call them is up to you. What you do not want to do is use k, because k is your constant of variation that was always going to be there. So let's say if you have a problem that involves kinetic energy, you wouldn't use k for kinetic, you would use E for energy. But you don't want to use k as one of these variables that you're setting up right here. Anything else you can use. All right. Any problems with that? Step 3, we can go ahead and write the equation. You know, d was the first variable, that's your y. T is your second variable, that's your x. And also it says the square of t, so that's why we have t squared here. So always pay attention to your details. Any problems, any problems? Next piece, next step, write down the given information. So they always give you all of the relationship from all of the information for the first relationship. Then in the second one, they give you everything except for one piece. And that's the piece you have to figure out. So notice in the first one, they gave us the distance that you'll travel in 2 seconds is 64 feet. In the second one, they give you 4.5 seconds and they want to know the distance. So they always give you all of the information in the first relationship. Then in the second relationship, you're missing one piece, and that's the piece you have to find. Any problems? We'll just give you a systematic way of solving these variation problems. All right, so step 5, use the equation in the first set of information to find K. So we use the equation and then this information to be able to find K. So we're going to substitute in D1 and T1 to the equation and then solve for K. Now scroll up on 4. All right, so 2, that's going to be 64 equal to K times 2 squared. Divide both sides by 4. And so K is equal to 16. Any problems? Any problems? All right, go ahead and put K into the equation. Now we have D equals 16T squared. Last step, we're going to use the second set of information in the new equation to find that missing piece. So you take the second time that they gave us, which is 4.5, plug it into our formula of D equals 16T squared. And that'll give us our distance.
Professor, is that use the second set of info and new equation?
Yes.
Okay.
Distance equals something times time, K times time squared.
Okay, wait, you sound right here?
Um,
Right here?
the D is distance, the T is time, right?
Yeah.
Okay.
Mhm.
Sorry.
Oh,
Slightly
that's
out
all
of
you,
it.
oh, say it again now. I'm sorry.
Sorry, I was slightly out of it.
Oh, okay. Okay, cool. All right. So is everybody okay up to step 7? And somebody asked me to scroll back up to 3 and 4, so I'll do that in a second. But is everybody finish copying step 7 first? Still see some copiers.
Can you tell me again where does K come from?
Well, now, are you talking about the variable K or the number 16?
The variable one.
It's a part of your setup.
Oh, it's just a part of, yeah,
Yeah,
thank
it's
you.
just a part of, yeah, it's your constant of variation. So all of these will have K in it. Yeah. So basically what happens in these variation problems, there's a constant that's gonna, be a significant part of that formula, that relationship, and K is that constant. So part of what we have to do is find out what is that constant to help us solve for the rest of it. And so, so K will always be a part. So somebody asked for steps 3 and 4. So there were 3 and 4 right there. Let me know when you finish and then we'll move on to the next. All right, not a problem. All right, so let's try this again. Very good for a scroll. All right. Next one, inverse variation. So y varies inversely as x, or y is inversely proportional to x. We have y equal to k over x. Now, our direct variation was y equal to k times x. This time we're setting up a divisional relationship, and we're doing y equal to k over x. All right, can I scroll up? All right, so when you use a spray can and press the valve at the top, you decrease the pressure of the gas in the can. Okay. All right, can I scroll up now? In general, if the temperature is constant, the pressure of a gas in a container varies inversely as the volume of the container. Give you a chance to write that. All right, scrolling up some more.
Does that red underlined word say varies
Inversely
inversely?
as.
Okay.
Let's see, where's the images problem? Okay. So the pressure of the gas. I could have wrote it better too. So the pressure of a gas sample in a container whose volume is 8 cubic inches is 12 pounds per square inch. If the sample expands to a volume of 22 cubic inches, what is the new pressure of the gas? All right, so that was a long one, but some of them are a little long. So, but you're gonna start it off the same way we did the last one. You look for your key phrasing, keywords that's gonna dictate how you're gonna set up the problem. So our key phrasing in this one is that inversely, inversely proportional to or inversely as. So y is equal to k over x is going to be our setup. All right. So after you set up, figure out what relationship you're going to use, then you set up your variables. Then you go back. Inversely, varies inversely as is right here. So what comes in front of that is going to be your first variable. What comes after that will be your second variable. So the first one is pressure of a gas. So I call that P. Next one after that, the volume of the container. So I call that V. So that's where I got P and V from. Once again, you can call them what you want, but I think it would be helpful to call it, something that's relatable. So you just don't want to use K because of the K that's going to be in all of your problems. All right. Then step 3, you go ahead and plug in P and V for the Y and X. All right. Gather your information. Once again, they give you all of one relationship, then in the next relationship, you miss one piece. All right. Step 5, we use first set of information to find K. So you plug in 12 for P, 8 for V, and solve for K by multiplying both sides by 8. And K is going to be 96. All right. Let's see, hopefully that's not too small. Somebody need to see 1 and 2 because you got kicked out. Yep, no problem. Everybody good? Can I scroll up? Step 6, just go ahead and plug in K into your equation, formula, whichever one you want to call it. All right. Now we plug in our information from the second set to figure out the missing piece. So we were missing the pressure, but they gave us the volume. And there we go. And of course, my math lab will let you know what they want from you. They want to answer in a fraction, or they want to answer in decimal, how many decimal places. You know, just make sure you hold true to what they ask of you. And there's your problem. There's your answer. I mean,
Can you scroll down a little bit more?
all right. So you're talking about like this, or
Yeah, the bottom numbers were cut off for
Gotcha.
7.
Mhm. All right. Somebody said something. Oh, okay. All right. So are we good with the last problem before we go to the next one? Everybody good? All right, so the next problem introduces 2 concepts. Combined variations when you use more than one variation in the problem. And then also joint variation, which allows us to set it up this way. If y varies jointly as x and z, that means we can have 2 variables on the right side, but it's still similar to direct variation. Notice how we're doing all multiplication, k times x times z. All right. So we got another problem. Is everybody done with combined variation?
Not just yet. Brain running on low this morning.
What does the green underlined word say?
Radius of. So is everybody down there? Can I scroll up? Anybody holding on to joint variation? Okay. All right. So we have the centrifugal force of a body moving in a circle varies jointly with radius of the circular path and the body's mass, and inversely with the square of the time it takes to move about one full circle. A 6-gram body moving in a circle with radius 100 centimeters at a rate of 1 revolution. So we're doing with centrifugal force. One revolution in 2 seconds has a centrifugal force of 600 dynes.
There's definitely a physics equation for this.
It just might be a smidgen of a physics equation set up for
A
this.
smidgen. I took physics in high school. I know there's an equation. If you want to blow your mind, take physics before you take pre-cal. Not a good idea.
Yeah, that'll do it to you. Of course, if I scroll up too far, let me know. See if I can get the rest of the problem in. So then to finish it off, it says find the centrifugal force of an 18-gram body moving in a circle with radius of 100 centimeters at a rate of 1 revolution in 3 seconds. All right, can you start the problem? All right, so first step, we need to sit up, check and see what phrasing is going to give us an idea of what relationships to use. So we had jointly and we had inversely. So if you go back up, jointly is right here, inversely right here. So you're always looking for those keywords, jointly, inversely, directly. They're going to let you know what relationships you're going to have to use. All right. Anybody still holding on to the black? Don't want to keep moving up and down if somebody's still copying.
Yeah, I'm still copying. What
Yeah, I'm
does
still
it say next to 6,000?
Dynes, D-Y-N-E-S. It's one of those physics measurements.
At the bottom under 100 centimeters, is that rate of 1 revolution or 2?
One.
Okay.
One revolution. Mhm. All right. Scroll up a little bit. Step 2 is to establish your variables. Like I said, I don't want to move off this black if somebody's still copying. All right. So I call C centrifugal force, call my centrifugal force C, radius R, M for mass, and then T for time. So once again, you're going to look at your phrasing, your jointly phrasing and inversely. So whatever comes before varies is Y, and that's going to be our centrifugal force. So if you go back and look, varies, what's in front of varies is your centrifugal force. Then it says jointly with the radius and the mass. So those are your two variables that vary jointly. And then inversely with the square of time. So that's going to be your relationship. That's going to emphasize, that relationship has to be emphasized inversely. So this is how we'll set it up. Notice inversely with time is on the bottom. That's why the T is on the bottom. And it was T squared, square of time. And then the jointly was your radius and your mass. So that's why they're on top. So this is considered a combined variation because we're using more than one variation in the problem. Problems with the setup.
I have a question.
Mm-hmm.
Now, I'm probably not going to say this word right, but I'm going to try. It's centrifugal? What?
Centrifugal.
Wait, why is it spelled that way? Because I was about to ask, is it centrifugal force? I hate English.
Yeah, centrifugal force. So it just depends on where you put your, your accent. Yeah.
Wait, so there's not a G there? Because that's why I think I was writing it like that. It looked like a G to me.
Mm-hmm.
It is a G?
Mm-hmm.
What the hell?
Don't ask me. I mean, I didn't look. I'm a math major. I just say it the way they told me how to say it. That's it. Why it works that way, is beyond me. So yep. So centrifugal.
I think like most physics terms, it's rooted in French.
That makes sense. Mm-hmm.
So it's some kind of English variation of some weird ass word that doesn't get spelled correctly.
I don't. Somebody said yes. Okay, good. Because I was gonna say I'm not. I gotta look up that centripetal. Centripetal. Have I heard that before? I'm gonna look it up. Yeah, that's a
They
good
use it
question.
in large tonnage chillers too, like for hospitals and big businesses like that. They're called centrifugal chillers. They
Oh,
normally operate. Yeah, they normally operate in a low pressure too, like in a
oh, okay.
vacuum.
Gotcha. Force that. That's when the body moves in a circular path. Centrifugal. So, but in centrifugal, acts towards the body moving to the center, rising inertia. Centrifugal. Yeah, okay. Center around the body's moving. Yeah, they're similar, but slightly different. Yeah. All right. Yeah, they're different things. They're different. They're similar, but they're different though. They are different. All right. So, step 4, looking at all the given information. All right, so they gave us 6,000 for 6,000 dynes, 100 radius, 6 grams in 2 seconds. The next one they asked us how many dynes. The radius will still be 100 grams, going to be 18, and then your seconds will be 3. So we're going to plug in all of our first set of information first so that we can find K. So remember the steps, all the steps are going to be the same in these problems. All right, so it's going to be 6,000 equal to K times 100 times 6 over 2 squared. Everybody done with 4? So 100 times 6 divided by 2 squared simplifies to 150. So it's 600 divided by 4 is 150. Then divide both sides by 150, and K is equal to 40.
I'm sorry, can we go over how 100 times 6 divided by 2 to the second becomes 150K?
Well, the K is right here. So that's not a part of the calculation. So 100 times 6 is 600. 2 squared down bottom is 4. So then you just do 600 divided by 4, and that'll be
Okay.
150.
How come you put the 150 in front of the K?
Normal normal process, just like you would have 5x instead of x5.
Ah,
Yeah,
thank
that's
you.
all. Yeah, no
Like I
problem.
said, I'm tired.
It's all good. And so initially, it was set up this way. So all I did was plug in each piece. And then after I simplified, I wrote the K behind the number. So that's all. Yeah. All right, can we scroll up? So now that we know what K is, that's our constant throughout the rest of the relationship. So just go ahead and plug in 40 for K.
Now, which t squared is that going to be? Is that going to be 3 or 2?
Well, next, you talking for the next step?
Yeah.
So next step, you will go off of your second set of information. So it would have to be the 3. Yeah. So we've already used that 2 in that first set of information. So now we're leaning on the second set. Yeah. So everybody done with step 5. All right, so going to what Mr. Williams was mentioning. So now we need to figure out the centrifugal force of the second relationship. So we use everything else. And so 40 is already given to us by K. We use R for 100, use 100 for R, 18 for M, and then 3 for T. And then when you simplify that, you'll get 8,000. 8,000 dynes. All right, questions on what we did there? Any questions? All right, anybody still copying? All right, so just do a recap real quick of our steps, because all of these problems flow with the same steps. Step 1, you first want to do is identify what your variation is. What keywords, what keyword or keywords are going to dictate the relationship. From there, you want to establish your variables. After that, use those variables in the equation that you had in step 1. So that's what we did here. We went ahead and wrote the equation. Then you always want to write down your given
Sorry,
information.
can you slow down a little?
Oh, okay, sorry. So then you want to write down your given information. So anytime you're dealing with a word problem, you want to make sure you write down your given information, because it's just easier to go back and reference versus having to go back here and try to pick out your information. Pick out your information initially and go ahead and lay it out so you know what goes with what. This is your first set of information. Then your second one was going to be missing one of your pieces of information. All right, so next, you're going to use that equation and the first set of information to find K. You need to figure out your constant of variation. Once you solve for K, plug that into your formula. And now you can use your second set of information to figure out the missing piece. So those are all your 7 steps. Those 7 steps will be the same for each problem in this section.
Can you go back to the beginning, 1, 2, and 3?
All right, hold on 1 second. So you're trying to copy them for the first time?
Yeah.
So give me a second. I'm gonna go back for you then. Yeah.
Sorry.
No. That's why I was going fast. I was just reviewing for everybody. But I'm gonna go back and make sure you have a chance. Versus, I'm not trying to rush you. I don't want I want you to be able to copy. So Courtney, before I go back up and give her an opportunity to copy this, questions on just those 7 steps. Everybody good?
Basically just word problems.
Yep, but with a specific
Formula.
Formula or setup or steps And so that, it's systematic in how you can solve all of these. Wherein, just general word problem section, there could be different types of problems. You would use something for this and different thing for that. And these are all same setup and all, you just use different variation. Yeah. All right. So we are done with chapter 3. The date that I set up for you guys, thought would be a good date for you guys to finish chapter 3 was November 14th, I believe. I haven't changed it in Math Lab yet, something I established with the last class. I'll confirm it in a second. Just giving everybody a chance to copy this for the first time.
Okay.
Make sure
write down.
everybody's good. But yeah, so November 14th. So now next class is going to be a review day for us. It was suggested to me to do a game from my last class. So that's what I'm going to try to do. I'm going to try to set up a game based on the test review. Hopefully, if I can do it right, then you guys will be able to earn extra credit and stuff like that. So it'd be, just a different way of reviewing. Monday, I'll probably still open up the floor for anybody who may have some general questions. Maybe, over the weekend, some questions got generated over the weekend. So Monday will be that, but Wednesday. Oh, yeah, so that's what was suggested to me, sir, to use Kahoot. So I'm gonna see if I can make it happen. But next class will be a review day. If I'm able to do that, the dean will be watching us play a game. So so that's how we're gonna flow. And if he had candidate we suggested to set up the first time, he would have got a lecture, but this time we're gonna get a game. So we'll see how that works. Hopefully it'll be good enough. So I don't know. We'll see how it works.
You said chapter 3 is due November 14th?
Yeah, so we'll do that November 14th. Let me see. Let me confirm. So for the person that was copying, are you good?
Yeah, I'm ready for 5, 6, and 7.
Oh, okay. Okay. All right.
Do you mind if I ask about recommendations for professors while she's copying stuff since we're done?
No, that's fine.
Yeah, that's cool. I don't mind.
All right. If anybody has a recommendation for principles of public speaking, history 111, I would appreciate it.
Yo, I gave you the history guy the other day.
He's not teaching, and I have to take 111, and he's not doing that one.
For principles of public speaking, I got a guy called Sean Ashby. Real good, real easy sort of lessons. Just like every week, gives us a bit of material to an assignment. Gave us a PDF for like the textbook sort of thing.
Okay.
And real simple class. Wasn't one of my harder ones.
So
You
if
give me a
anybody
sec,
needs
I
to
can
take
pull my.
What you say?
If anybody needs to take psych, Mr. Person, Moselle Person, pretty awesome, real chill class. Definitely recommend anybody take any of his psych
Person
classes.
for psych?
Yes, Moselle Person.
Psychology. Oh, gross. No, thank you. I'm a math person, not a psych person. God, no, thank you.
It's so easy if you have to take it.
Use the equation of percent.
All right. So yeah. So as far as chapter 3 goes, come next class ready for review. The way Kahoot works. Somebody asked me, was I only teaching in person next semester? No, I'm actually doing some Zoom classes and then some face-to-face. So I haven't looked to see which ones. I think I have 3 Zoom and then 2 face-to-face. It's something like that. But they're trying to gradually bring us back to face-to-face. So they're trying to go at least 50% face-to-face with everybody. So yeah, so I have to go and look and see which classes. I know I have a pre-calc too, if you're asking about that, but I don't know which one, if it's face-to-face or Zoom, not. Because I know initially he did all face-to-face, but then he switched some of them to Zoom. and then some of the face-to-face. So I had to go check that out, see what he actually did. Talking about the department head. Yeah.
You scroll down just one little bit.
Yep. So I think that's it as far as chapter 3 is concerned. We'll be reviewing next class. And then Monday we'll open up the floor for review as well, just to make sure if you don't have anything, then we'll go ahead into chapter 4. And then your due date for all of chapter 3's content is going to be November 14th. And then as always, if you have any issues, make sure you just communicate, that extension day, not extension day, that due date comes up on you quick or something like that. Then, talk to me. Just talk to me and we'll make it work. All right. Any
Dawn?
questions before we close? Oh, somebody said something to Dawn.
Yes, ma'am.
If you're looking for a history professor, Mr. Eberly is really good.
All right, thank you.
Yeah, he lectures and then he types all of his notes into the chat, and then gives you take-home tests for like a week to do them. I took his 8-week course and got a B. So
Awesome, thank you.
yeah,
That sounds like a good setup.
yeah, he's lit. You don't even have to pay attention. It's great.
I don't know if I want to encourage that, but I feel you.
Hey, history, not my thing. Easy professor, yes, thank you.
So if you guys are good, I'm good. Like I said, look, I'm gonna try to do that game thing. Hopefully the thing will work out and it can do it the way I want to do. I got to play around with it. Other than that, see you guys on next class. Said come ready to play and keep the cussing down to a minimum because the dean will be in the room. Other than that, you guys have a good one. I'll see you next class.
Have a good
Thank you,
day.
Professor.
Thanks. You do the same. Take care.
Hey, Professor, did you get a chance to check on that applied calc class yet?
Have not. Let me hit the I'm gonna hit the dean up. Hopefully I have an answer for you by next class.
All right, yeah, just shoot me an email if you find out before then. Otherwise, I'll just ask you then because I think they open up early
Registration.
That's the word. That's the word. I haven't had coffee yet, man. I'm trying
It's all
to.
good.
I was getting up to like 3 cups of coffee a day. I'm trying to like slow my roll a little bit. But that's the word. Yeah. And I want to make sure I get in. And like I was talking to you about in office hours, if I got to try to do it somewhere else that works with TCC, then that's what I want to do as well.
Right.
But I want to get on it too late type situation.
Gotcha.
Cool, man.
All right,
Appreciate
man.
it, bud.
Yep.
Have a good one.
You do the same.
Professor,
Mm-hmm.
when you find out if you're going to be doing the next math class on Zoom, will you let us know?
Yeah. Well, I know I'm doing well. I told him to put me down for PreCalc 2 because I had a few people that was asking for PreCalc 2 from me. Even if I do it face to face, I will probably create a Zoom option. I will create a Zoom option because I already have those lectures pre-recorded anyway. So it will be a Zoom option if you just want to take it with me, but you don't want to meet face to face.
Yeah. Okay.
Yeah. So if that's your flow, then just let me know and we'll work it out. So.
Okay. Do you know what the school's policy is going to be? I know that it's mandatory masks on campus. Do you know if there's going to be a vaccination policy when they return full time?
I don't know. I would think probably yes, because TCC and Norfolk State are funded by the state, and a lot of things, whatever Norfolk State do, is mandated on TCC and vice versa. And Norfolk State making people get vaccinated.
Okay.
So,
I mean, I have mine. The military mandated it, so
Gotcha.
I mean, I'm good to go. Just want to make sure that they're.
Yeah, I think that's going to be the case. It's going to be probably mandatory vaccine and wear your mask. Yeah.
That'll be interesting. We'll see what happens with that.
Right.
All right. Thank you.
All right. Take care.